Okay, so Andreas, feel free to take it away and talk us through incidents.
Yeah, good morning, good afternoon, good evening, wherever you are on this planet. Yes, incidents happen, as much as we don't like them, because incidents is always a little bit of negative energy around in the planet. But we need to have intelligent people around and enough measurements, countermeasures, and so on. We have eloquent guests here in the webinars, and also people who are pretty much in charge of taking care about that what we are talking here for our Satellite Innovation Group members. So the environment is pretty clear. It has not changed very much during the time of the COVID break, of the home working or whatever. Incidents continue to happen. Incidents continue to pass, to be resolved, to have the people involved in it. We are looking at capabilities that suddenly went away from office environments and coordination between people, because you're just sitting next to somebody. Now taking a phone call, taking a Teams coordination, taking a little bit of chat via telephone, via whatever kind of means you would like to have. It's a never-ending story of video conference tools in this environment. And we have seen very clearly, and that's the feedback also from major satellite operators who are our members, that the numbers of resolving, the numbers of treating, the numbers of ticketing, that has not very much changed over the time of this confinement period since March 2020. So we are looking into a pretty solid performance and good environments into the handling of the ongoing incidents and problems. It is pretty clear, and I have not actually expected something else, because the ETL processes, which we all are following in somehow way or the other, together with the ISO certificated procedures, which we have in 9001, or for security reasons 27001, they are all set. And no matter where we are, no matter where the people, where the control centers are, where the guys of the support offices are, these will be applied. And this is something which we can see very clearly. There's no change. For sure, in request fulfillment, it's a complete different story. But that is a different topic. And as you know, request fulfillment is everything which is pre-approved. So like PTLUs, prior to lineup checks, measurements, pick and polls, and these kind of things, what geostationary satellite operators need to do and need to make sure that that is going on. We had a drop that is very significant, and even up to now, there is not yet the same environment back as we have had it before. But with incidents, no change. Right from the beginning, same numbers, same things, but we have learned one particular thing. We learned that organizing it, even while we are not in office, is very much possible, and it is very much even organizable in a distributed way, as such that one is, for example, in Italy, the next one is in the United States, the next one is sitting somewhere in France or in Singapore or wherever. But the whole coordination works extremely well, and I'm very, very pleased to see that, we can actually work together. And neither the cooperation between the satellite operators, whenever we need to have something like an ASI check or whatever kind of thing where more than one satellite operator is affected, no, is all fine. It's all going on. It's all positive, and we have learned to live with the new communication technologies. Everything just went a little bit super virtual, and I would say we're ready to go that path even further and think about how we are able to have more percentage, maybe even forever, in a certain amount of home working and being called into the office whenever there is necessary. The work home and the work private life balance is very much changed due to this pandemic, what we have, and not for the negative, not for the positive, neither for the business environment, nor for the private life. We've just taken it up, and as a pilot would say, we have just ride the bumps and everything fine. Now we land at the airport and we release our passengers and everything fine. Back to you, Hel.
Thank you, Andreas. That was very good. So the idea with these is to also give members a chance to have a short presentation about something that they're doing related to the topic.
This presentation was provided in last week VTrans, and it will be available at the VSF channel in the YouTube. So I'm going to run very fast. I'm not going to stop on the big things. So please bear with me. I only have 5 minutes. This is a aim to go 25 minutes. So basically I'm outlining VideoFlow, and I'm running fast. What are the satellite service challenges that we see, and I'm also working in a group that tackling this issue. It's a C-band group in the US, and these are the notes that we came with. So the first thing is 5G and C-band coexistence. One of the problems that some people said is that there is no US federal oversight of cell tower installations, specifically microcells location, meaning that anybody can put microcells or 5G towers without notifying the earth station operator. And this is a big hassle because you have an interference. You just don't know where it's coming from and why did it happen. Then the question is for filter selection, as is advised to the users, and I will touch base on that. There's the adjacent satellite interference planning, and interference coming of poor planning or in compatible dish alignment. Some uncontrolled radio sources by way of military radars, FM transmitters and jammers, weather conditions and sunspots, aging equipment, which is a very big topic in the US that need to be switched and replaced. And one of the biggest things that we identified is training and education to the earth station people, that some of them, a lot of people left the industry, newcomers come in and don't understand the basic workflows and the technologies, and that has to be done. And I hope this group and others will touch base on that. Next, this is how video goes seen when you have an interference. I'm jumping. This is about to those who don't believe in sun flares. I have to explain to them that this is happening. This is a real reality that's happening all over the world, and interference will come and they will disrupt your service for several minutes and might be somewhat more. Some background about 5G interference at C-band, the frequency sharing site, and how you need to take care about that. I'm jumping, running very fast. Some filter selection and what you have to do and how do you have to cope with the problem, and whether filters are the real solution to the problem of 5G and the C-band. ASI, some people don't understand what is ASI because they think it's the responsibility of Intelsat, Eutelsat to do that, and not, they should not care about that. And we are telling them, yes, you do need to care, you need to know about this problem and be aware of that. Jumping ahead. And how people think to resolve satellite interferences. So the easiest one, use another bird, use a backup link from another satellite. This is the easy one. Bundle geographically separated earth station. Some people say, I would put one in, I don't know, San Francisco, another one in Iowa, and we will do a switching between them if something happens. Increase the transmission beam power, increase the diameter of earth stations. It was found that many earth stations in the US don't have enough diameter in the dishes. They need to change the entire dish array. Add filters against rogue frequencies, prevent 5G equipment near earth stations. Yeah. Reduce the content of or the service by way of better encryption, HEVC, and so on. Then they tell them to monitor nearby interference sources, try to add an IP-based failover link. And the biggest thing is track and register interferences, meaning that you have an event, just register that, raise a complaint, but at the end of the day, you are suffering, your customers are suffering. So just going forward, VideoFlow coming from the IT world, or we've been doing reliable streaming on the internet. It's our own technology. We wanted to bring a solution that will tie up satellite and IP, not to switch between them, but rather to augment the satellite delivery. We believe that the satellite can still be the major carrier of the signal doing its broadcast activity, and we will apply IP to recover packet loss. And for that, we believe that we can use any type of IP link. It can be basic low-cost internet. It can be LEOs, broadband, terrestrial, anything that can carry a download bitrate, and it doesn't have to be that much. I don't have to recover the entire bouquet if I don't need that. If I have 1% packet loss, I need only 1% of bandwidth to cover that, maybe some more. So what are we doing? We basically, I'm going to go to the next slide. We're basically leaving the standard delivery system untouched. We still have the MCR, we have the up converter going to the bird and to the earth stations. Nothing has changed. So you can either use it or not use it. What we do, we add 3 elements. We have an origin device at the source to pick up the signal before it going up to the bird. And then we're using a secure, reliable tunnel to send it to the cloud to an entity called the recovery server. That recovery server stores the stream coming from the source, and it receives requests from data recovery clients that will touch base and provide them the remedy needed in case they have interferences that will cause artifact by way of packet loss, TEIs, and we will recover those. So the most important piece of this riddle is the recovery client. What it does, it sits and monitors the satellite outcome, identifying missing data. And mind you, the data is in transport stream. There is no sequencing that you can compare it with. You need to identify where is the data, aligning to, and try to somehow align it to the data that was originally sent. Send a request for that missing data to the recovery server to get a remedy, and merge that remedy, that packet, that missing information back to the original stream, so the outcome will be a seamless splice. So that is how the system now looks. So we added the VideoFlow parts. We're taking the source, tapping to the source, hauling it to the network, to the cloud, where we have our servers that can treat tens, hundreds, maybe thousands of clients. Keep in mind, we are not streaming to them, so we don't consume that much of a bandwidth. All we do is keep a live link to those clients that are now residing in the receiver side. They can be after the IRD, but in some cases we'll also put them before the IRD. It depends on the functionality that the IRD needs to perform. So now we have a keep alive. We have a connectivity to those receivers. This also allows the MCR to monitor the health of the reception, something that today is done by the receivers themselves. Now we can make it available to the MCR, so we can see what is the reception all over the place, not not wait for a phone call, but get it from us. So once there is some packet loss, in this case 10% packet loss, interference to an earth station because of 5G, whether we don't care, that client detects that problem, sends a request to the recovery server to recover that packet. The data is sent to the earth station for recovery, and we get 0% packet loss. Now, we designed the system, this solution, to work up to 10% packet loss. Usually, you know that more than 1% packet loss in the satellite is a nightmare. We try to push the bar forward to 10%. And if we can do that, the idea is that maybe some of the LDPC or FEC can be removed in stations that fully deploy a VideoFlow solution. So the cost of sending over the satellite will be reduced somehow. So let's see that. So to those who don't understand what we do, on the bottom left, we have the original stream that we are sending to the cloud. On the middle is the satellite output, and a piece is missing, corrupted, missing. There is an indication that the TEI bit is on, so it's a corrupt packet. We identify this situation. We notify a recovery server to send us the missing piece. It can be a single TS, 2 TSs, can be hundreds of TS packets to be sent back, to be spliced back to the original location and output that. So in fact, it is seamless. To visualize it more, there's a 25-second clip.
Let's see how VideoFlow's RISE can overcome these challenges. In a regular operation mode, a video transport stream will be packetized and streamed to satellite and down to the received stations and further distribution. RISE offering includes software at the transmission station, a cloud server, and VideoFlow software at the satellite receiving site, all connected via any type of IP link or even internet. At the uplink station, the video stream will be transmitted simultaneously to the satellite and to the IP network cloud. A lighting interference emerged at the satellite uplink stream and damaged packet number 2. VideoFlow software platform gets its input from the receiver, automatically detects the specific damaged packet or packets, and sends a request to the IP network cloud for a packet replacement. Once received, the video stream will be resynchronized and sent out smoothly. All of this done seamlessly and no effect to video continuity.
Okay. So going forward, what happens if we have a complete satellite disruption? To that, we add a fourth element, which is called a backup server. The backup server also has an access to the original stream. So then if something like that happens, the client can be directed to notify a backup server to start sending data to it, 100% of the data to that client, meaning that it can use any type of reliable streaming method, SRT, RIST, VideoFlow, ZigZag, whatever. Of course, because this is our system, we would use something that we designed. And as soon as the satellite comes back, it will automatically switch over to a seamless splice back so that the user doesn't know that anything happened. This reduces the load on the network. This reduces a cloud bandwidth cost. So the backup server is just in waiting. We don't need that. As long as you don't need that, it's just sitting there in waiting, just like a disaster recovery system that you use the cloud to do. So going forward, to summarize, what are the major benefits? We are overcoming satellite link interferences by way of a non-intrusive solution. We don't no bitrate increase to the satellite link. It seamlessly recovers any missing data in the satellite link. We strive to do a hitless changeover from the satellite link to the IP link and vice versa, unlike solutions that are switching between SRT and satellite, and they are jumping all over the place without synchronization that by that definition create artifacts. We increase the operational efficiency. We cut the number of truck rolls with secure indent management to the remote site, meaning that the user can connect to the remote site from the MCR or from, we can do that for him, and to control our device or any other device that is in the site for the purpose of monitoring or management. We increase stream collaboration and decrease the mean time to repair any incidents. We provide confidence feed return if we request it. We can provide confidence monitoring, which is something that was not there before. Each unit can perform an ETR 290 stream monitor with events. So the MCR knows what happened, and also the air station people know what is happening from the comfort of their home. Just think what Andreas said about COVID, working from home. Now using the IP will give you better statistics and handling of what is happening. And of course, live network statistics that I did not mention. So those were my 5 minutes. Thank you very much for your time, and I'm open for questioning.